Yeah, it should be better to just turn off the video feed. This should be
Yeah. So my voice is clear, right?
yeah, it's good.
Okay. Let me share my screen. Do let me know when it is visible. Uh, is it visible now?
Yes, it is. Yes, it is.
Yeah, yeah. So let's continue to the purpose of our presentation. As I said that purpose is regarding getting up the fundamental principle and patterns for robust software design. So importance of it. So we want to get to the importance of it. Why we need this solid principle and design pattern. Why we want to implement these things? Because we want the essentials to be made up, which is scalable, maintainable, and extensible software systems. So these are the three requirements. To adhere this requirement, we need solid principle and design patterns. So for the structure of the presentation, I'll be giving you the overview for the solid principle, and then I'll be exploring with I will giving you the topics to explore on various design patterns. So yeah. So on the next slide, it is more about the solid principle overview. So in this, we will be looking at the abbreviation of the solid, which is S for single responsibility principle, O for open close principle, L for Liskop substitution principle, I for interface segregation principle, and D for dependency inversion principle. So these are the abbreviation of the solid. Let's explore one by one by the code examples. What we meant by this. Can you guys see up once?
Yes.
Yeah, yeah. So okay. So let's start with the solid. So let's start with the S of the solid, which is single responsibility principle. So what does this principle states that a class should have only one reason to change, meaning it should have only one responsibilities or job. So by adhering this principle, what we can make it more cohesive, easier to understand, test and maintain. So let's see how with the example how it is done. For example, this is an user class. A user is having a username and password. So here we are creating the user, deleting the user, authenticating the user, updating the profile, and viewing the profile. If you could see in this code that we are doing ton of things that can be segregated out. So here we are for a particular user, we are doing create operation also, delete operation also, authenticate also, updating its profile also, viewing its profile also. So here we are doing multiple operation according to the solid principle, as of the solid principle, which is single responsibility. It would be better if we can segregate it out. The classes can be segregated it out and can be effectively utilized as per having only one responsibility. For example, if we segregate it out to a user authenticator, so this user authenticator class would be having only one responsibility, just to authenticate by providing the username and password. This implementation for this for this class, and also like it is more clean kind of thing for this user authentication. So one of the class we can segregate it out like this. Another class would be user manager class that would do the managing stuff, that is responsible for creating of the user and deleting of the user. Another is the user profile class, which would be more responsible towards the profile related information, which is the updating the profile and viewing the profile, right? So this we can so this how we got knowledge, like from the big user class which is doing a tons of thing. We segregated it out to a simple classes which could do a single responsible thing, which is related to its more more related to its core functionality, which is regarding the profile itself, regarding the managing create users, and another is the authenticating users. So this stands for S of the principle. Now let's look at the O of the principle. Meanwhile, take a quick uh, I'll just take a quick call from you guys that it is everything clear from my side. Q&A session at the last, it's just clear. You can raise your hand. So just it is clear from your side. So we can continue to the next slides. Hello, hello.
Yeah, yeah. It's Emmanuel Jason. It's clear. Yeah. People says it's clear.
Okay, okay. Yeah, cool. Let's jump up to the next principle, which is open close principle. Like let's jump up to the next principle, which is open close principle. So open close principle, like by definition, software entities should be open for extension and closed for modification. Why it is so? Because writing up a class for a particular feature, and then we want is earlier written by any of the developers, so that it the previous code doesn't get into bugging. So we want to write in such a way that the class should be open for extension but closed for modification. The class shouldn't be modified. We will explore this on the basis of the example. Let's get into the importance of it. Uh, why it is why it is important? Important is because of the extensibility and scalability, also the maintainability, that it reduces the risk of introducing bugs in the existing code. The bugs would be reduced because we are not touching the existing code, we are just adding up to new things which is separated out from our existing code. So let's try to understand this principle from the example. So I am on my IntelliJ screen. So yeah, so in the payment processor, let me introduce one class which is payment strategy class. So suppose you have a we have to pay an amount. We have different strategy. It could be a credit card strategy, or it could be a PayPal payment. A credit card, there could be a different. So in our initial days, our app only supports the PayPal one. In later days, it started supporting the credit card one. So in our initial days, one of the our developers just pulled up this interface, that is payment strategy, where he could just give up the amount, and it would adhere to paying this amount. So then the PayPal payment strategy was implemented by implementing this interface, and this interface does a dummy kind of thing where the actual logic would be to pay an amount via PayPal. So now in the driver class, we can just set up the payment processor class, and then in the payment processor class, this is the payment processor class. This would be taking up one strategy, which is the PayPal payment strategy. So this strategy would be setting up via this setter injection. Then on the process payment, the same strategy would this will be completing this PayPal payment from the payment processor strategy. Later on in the software development life cycle, some new requirement came up, and we have to integrate credit card also. So to integrate credit card also, you see, we don't have to modify any of the codes in this or this. We just introduce one more strategy, implementing credit card payment strategy, implementing payment strategy, and then we just adhere to the driver code, which is responsible for using it. So driver code could be modified. This is responsible for using it.
Hello,
Responsible for using it. So here we added the hello.
yeah, you cut off for a second there. You can
Sorry.
you got cut off for a second, so you can continue.
Okay. 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 Yeah. So as I was saying, that our previous classes, payment processor, payment strategy, and PayPal payments, all these three are not changed with the new implementation of the credit card payment. So this is adhering to the principle that our code was open for extension, since we have provided an interface, anyone could implement it and provide an extension to it, and it was closed for modification. This was closed for modification because we didn't know, we didn't have to modify any of the pre-existing classes in it. So this was responsible for the open close principle. So as I have mentioned that open close principle, a system having new features could be added frequently. Adhering to OCP is that designing component in such a way that it could be extended without altering the previous source code. That means it is, the risk of bug would be less in this code. So as the solution I have showed to you and the benefits is adding up the new feature won't be impacting any existing functionality. So this enhances code maintainability and stability over time. So yeah, so this is all about open close principle. Yeah. So coming up to the next principle, which is Liskov substitution principle. Before coming up to the new next principle, I'll just like to get a thumbs up from your side to just to know that if everything looks good to you guys.
How's the audience? Is it good? Y'all give some thumbs up. Okay, we're seeing one thumbs up. We're seeing two thumbs up. Anyone else?
Yeah, cool. I understand that it is little bit tough topic for the people who are going to college, basically because this is even tough topic for the people who are working at industry, because people who are working or industry is also not following this principle quite a lot, because I think due to lack of knowledge or lack of the resources out there, which is guiding in such a brief about that, how we should make our code more robust. So meanwhile, it is the best time to get up with some of the principle. I am trying to explain with a very simple solution, very short solution, so that you guys can get an overview of it. And I'll try to explain the next one also, the which is the Liskov substitution principle. So basically, all this principle and design patterns comes under the object-oriented concepts. So people who would be knowing of the object-oriented concepts would be getting little bit ease on this up. But as I can make you understand on this, so it would be in a way simple manner. So let's start up with the next one, which is the Liskov substitution principle, which is L of it. Most of the people, this is one of the hardest principle to understand with. So object of superclass should be replaceable with the object of subclass without affecting program correctness. Let's try to understand what Liskov substitution principle is by the code example. So yeah, so let's check so this is an interface which is an I employee interface. So here we have get salary method from this interface, and we have another perks, get perks. So you would be thinking that we have separated out into two different interface. An employee can have bonus and an employee can have perks also. So why do we need to separate it out in these two interfaces? Why make more more interfaces, more number of more number of stuffs coming up in this? To get this, let's look at what changing. So if we look at our employee, so it permanent employee, another is the temporary employee, another is the temporary employee, and another is the contractual employee. So if you look at the permanent employee, so the permanent employee always gets the bonus, gets the salary, and it has all the perks which is associated with the company. Whereas with the temporary employee, there could be a bonus, there could be a perk or could not be, and there could be a fixed amount of salary which it is having. But in case of contractual employee, he just gets the salary, no bonus or perks he gets from the company. So here we identify that we have separated out the employee in the basis of its responsibility and how it could change in future. So this makes our code more towards what we want to align with future. How? Let's see by checking up an example, which is this example. So suppose we want to check the total salaries of the employee, right? Contractual employee or permanent employee or temporary employee will have all these employee would have salary. So this fetch total salary would be just we can pass up the employee list, which is Sunchit, Surbi, and Rahul. So this three employees are there. We have added, and this having employee ID. So we can just pass it up using this up, and then we can just get the total salary of every employee, sum it up, and then we can return from this method. So this would give us the total salary of the employee. So and what if we want to calculate that what are all the special allowances he would be getting? So we can check that the allowances interface is supported only with the employee of type permanent and temporary, not of contractual, because contractual employee won't be getting any allowances. So if we try to just add this contractual employee in this code would be giving us that required type is this, it is provided this, so the type doesn't specify. Why does the type doesn't specify? Because we have separated out the interface for the permanent and temporary employee, and for the contractual employee we have just extended the employee, not extended the other class. This is the employee class, which is having implementation of the I employee class. So this would help us to get the all the bonuses of those employee which are having which are having this which are having this perks and other facilities associated with them. So the main crux of this point was, or this example was related to separating out these interfaces in such a way that the subclasses which we want to create should adhere to the requirement which would be developing in future, so that now so that our code becomes more resilient towards the changes. So this is one of the example of Liskov substitution principle. So this was bust out of the internet. So I have pulled up the resources from different people, different channels which are making up the things to make it understand in a more simple way, so that I can deliver it to you guys, so that you can just try to integrate with your solution or your code base. So this was one of the example of scope substitution principle. So let's start with another one, which is the interface segregation principle, which stands for eye of the solid. So the client should not be forced to depend on. We usually, while making the Spring Boot interface, we make the interface fatty. One interface could have multiple methods, and then we, whenever there is a code change which is coming in, then we define many of the implementation of it as null. So that is violating the interface segregation principle, I of this solid. So let's try to understand this with an example that is using solid. So this is a very basic example, which is a fax interface could fax it, a printer interface could print it, and a scanner interface could scan it, right? If someone would have clubbed all these interfaces to one interface, all in one printer, or all in one things, then any of the basic devices, for example a basic printer, would be implementing, then it would be providing the null implementation of this other things, which is the if it is a basic printer, then it would be providing null implementation for fax and scanner. But since we have these separated out the interfaces for doing exactly one stuff, or exactly the responsible stuff which it is for. For example, a fax interface is just responsible for doing fax, whereas the interface is responsible for just doing a print, and the scanner interface is just responsible for doing scan. So it's more similar to single responsibility principle, which it is aligning with. And then we can see that our basic printer, we can just implement the printer interface and provide its implementation. In the basic scanner, we can provide the scanner implementation and provide it. And in the driver all-in-one printer, we can implement all the three, which is having the printer, scanner, and fax. That is having all the three functionalities. So this is the driver class that would be basic printer can print and the basic scanner can just scan. So yeah, so this is the overall functionality of this. So what we have done out in eye of this interface segregation principle, so that they don't bulk up and we don't need to provide null implementation for it. So yeah, so this is eye of the interface segregation principle. Okay, so you guys are good with this till now?
Thumbs up if you guys are good with the explanation. You want to see thumbs up. The audience.
Yeah.
Okay.
So I guess it will take some time, but I will provide the link and details in the description, in the end of this description, so that you can just go to the GitHub link and can check all this implementation once. So yeah. Let's start with the other principle, which is D of the dependency inversion principle. D of the solid, which is dependency inversion principle. So we all are using some sort of framework to manage this in Java. It is more about Spring Boot, which is managing the dependency inversion principle, which is the high level modules should not depend on low level modules. Both should be dependent on abstraction. So what does it means? That we want to loosely couple and provide flexible and facilitate easier testing and maintenance of the code. So how can we do that? Let's try to check the dependency inversion principle. Uh, let's try to check up with the interface first. So this interface is the message service. The message service would take up on send message, which is the responsible for sending message. A message could be of two type. Either it could be an email or SMS. So this interface would be aligning with both of them. The email service, which is trying to implement this, would implement this message service interface and this send message method, which is sending out the email to this sending out to the email. And another one is the SMS service, which would be also aligning with this send method, which is sending out this SMS. In the notification service, if we see, so we in the notification service, we can just put up the dependency of the message service. Either it could be an email message or the SMS message, and that would be pulling up to the pulling up to the responsibility of sending the message. So this message service dot send message is called on this interface. So this is the send message notification service implementation. So without knowing the fact that whether it is a kind of an email service or SMS service or any another kind of push notification, we can just add this kind of service here, and then we can just send the message. So it promotes loose coupling. If you can see with this example that I am not checking out the concrete implementation of what it is doing from SMS service or email service. I am more checking out to like how it is doing, that it is what it needs to do, which is that message service needs to just send a message. So anyone who would be implementing it is pluggable to notification service. So let's try to understand with the driver class. So this is the message service, which is the email service, and this notification service, which is which has been plugged by the email service. This email service has been dependency injected into this notification service, and then we simply call send notification method of this so that it tries to send the notification. Similarly, for the SMS service, we can see that we injected the SMS service in the notification service, and then we can send notification to this, right? So we can see that here is the loose coupling that we define. The email service and the SMS service are been auto pluggable, and this is the dependency inversion which we are following up. This is one of the most important interview questions. If you guys get aligned with any of the interview questions, then most of the question would be around solid, anywhere between 1 to 5 years of experience. If you have greater than five, it would be more about coding this solution into the actual implementation during an interview. So this sums up the solid as an overview. So yeah, I'd like to hear
Any comment regarding the solid principles from the audience, perhaps? The chat, if you like to. Because it's a very interesting, very topic for us to understand. So especially if you are going to work at the industry. The audience would have a response or comment regarding the solid principles. Now we could continue on to the next
Yeah, I
agenda.
think we can, yeah, we can move on to the next agenda, which is regarding the design patterns.
Hello?
Overview. Okay, so what are design patterns? So design patterns are reusable solutions. Hello, yeah, Matson.
Yeah,
Hello,
you cut off for a second. Yeah. You good now?
yeah. It's my.
It's good
Am
now.
I
It's good.
audible now? Yeah, Matson. I'm
Yeah,
audible
yeah,
now. Yeah, yeah. So yeah.
yeah. You are audible. We can listen.
So yeah, yeah. So talking about the design pattern overview. So what are design patterns? These are the reusable solution to common problems encountered in software design. So the importance is regarding the promoting code reusability, maintainability, and scalability. These are the proven solution that often happens to the recurring design challenges. We might be coding a lot of things, but we might be reiterating those problems which have been already solved up and documented well. So these solved up solution to make the code more reusable, maintainable, and scalable are been proved as design patterns and has been subjected to documentation by the Gang of Four. So let's talk about design pattern, which is we have three types of design patterns, which is creational, structural, and behavior. So creational is more focusing on object creation mechanism, how the object is created, in responsible with the object-oriented paradigm. And the structural is concerned with the object composition and its relationship with different objects, whereas the behavior pattern is related to more about the communication between the objects and their responsibility. How do the object communicate, and what are the problems we are getting while communicating with one object of another type? So we'll be delve deeper into the each type of design pattern. I'll provide the examples for it. So for the creational design pattern part, so creational design pattern deal with object creation mechanism, as I said, and trying to create a object in a suitable manner to this situation. Importance is that object creation logic can be encapsulated, promoting flexibility and maintainability. We have a way out to decouple the client code from the actual object creation code, and there are different creational patterns for it, which is the factory, abstract factory, builder, and prototype. So each creational patterns addresses specific requirements. Similarly, we have structural patterns. So we just go through the slide once, and then I'll give you a brief overview. The structural patterns focuses on how objects are composed to form larger structure, how they are aligned to design of flexible and efficient object structures. We would be looking into it, and the creation of complex system with minimal coupling. Like we want to reduce coupling in the system so that like the objects are not tightly coupled, they are loosely coupled so that it could be easier to maintain and easier to add new functionality into. So the types of structural patterns are adapter, bridge, composite, decorator, facade, and proxy. So the last one is the behavioral design patterns, which is more related to the communication between the objects, how they interact with, and how they interact and their responsibilities. The types of patterns are observer, strategy, command, iterator, state, and template. Behavior patterns help in designing systems that are more adaptable to changing requirement and promote a clear separation of concern between objects. So more about how one object communicate to another object. So this is this is one of the this is the three of the patterns. Let's try to get few one since all of them are not possible to cover in just a short span of time. I'll just cover up a few from one of those. One is the factory pattern, which usually people in their day-to-day coding create that how like we get the objects from a factory. For example, let's define a document. A document is an interface that has open method. And other one is related to document factory, which is creating up of document. So a document factory would be responsible for creating different type of documents, which is the text document and the spreadsheet document. So the text document, if you see, the text document would implement the document class, and it will be having a feature to open itself, right? Opening a text document. Similarly, the spreadsheet document would be having a feature to open itself. But we want the factories to be responsible for creation of this object. So I'll just create one spreadsheet document factory that would be implementing this document factory, and then we can just call the create document method, which we defined in the document factory interface. Then it could return us the spreadsheet document. Similarly, in the next part, which is the text document factory, it also implements the document factory, and it could be created using the text document. Like the new object would be created using this. So what we are doing here we are just separating out the responsibility of creation to an factory method, to a factory class, which has a specific factory method to create the document. So if we look at the driver class, now our driver class is quite clean. The the text factory is responsible. The document factory would give me a text factory that would be defined from the new text document factory. Then I can just create a document from it, and then I can open the text document. Similarly, from the spreadsheet factory, I can get the spreadsheet factory object, and then I can just create a spreadsheet document from it, and then I can open it. So this provided a loose coupling, and the object creation responsibility was given to the factory classes instead of maintaining it in the driver classes or giving the responsibility to one particular class. So this is about the factory design pattern. This is one of the most used design pattern in our day-to-day life while working in the coding environments.
Recording stopped. Recording in progress.
So this is factory design pattern. The other one, let's look at the behavioral one. In behavioral one of the most important design pattern is the strategy design pattern. We must have heard of bubble short, quick short, and merge short. These are the different implementation of shorting. So basically, these are different strategies to short the data. So suppose we want to short by providing different strategies. How can we do that? So one easier way and a clean way to do is using the strategy pattern. So we defined an interface shorting strategy. We just created the short method of it, and then uh, in the in the uh, in the bubble short, we tried to implement this shorting strategy, which would be taking an integer data array, and then we will be calling up its own method, which is its private method related to the bubble short class only regarding its implementation. Similarly, in the merge short, it would be calling this short method with the same data, and then Its internal implementation would be a merge sort implementation. Two procedures. One is this merging process, and other is separating out data to small chunks using divide and conquer strategy. So this is the merge sort strategy, and another is the quick sort strategy. I did three implementation of it. Now in the driver class, if you look at that, then this is the interface sorting strategy which we have defined. Now we can have three of them, which is bubble sort, merge sort, and quick sort. And we have defined one sorting context here. What is sorting context here? Sorting context is a class that takes up a strategy and then it performs sort. So based upon the strategy, it's called its short method. Since this short method is common to all these sorting strategies, so this short method will be called. So if you look at this context is, and I passed it as bubble short, then context dot perform short will call the bubble sorting logic. Similarly, if we set the strategy to merge short and we call the perform short method with this context, then the merge short strategy would be called, and quick short would be called. So if you see here, the object interaction here, how we just segregated out and made it quite clean from the official implementation of what we did in case of these three strategy classes. In the driver class, we just segregated it out, and now if you see, if we if I like call upon this, so you can see here that the bubble short is called, merge short is called, and quick short is called separately out. So this is the sorting strategy design pattern. This is also one of the most used behavioral design pattern. So I've covered one from all of them. I'll provide the GitHub link for this so that you guys can check it out regarding any of the design pattern mentioned here and can ping me up if you need to understand any of them. So in the structural pattern, let's try to understand the structural pattern. So for structure pattern, we could pick the 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 decorator pattern, which is also one of the often used one, which is the suppose we have a coffee has the cost associated with it. Now in the coffee we want to create a decorator around it, means that we want to just have a coffee of different kinds, which is a simple coffee or a sugar coffee or a milk coffee, and would have a different prices of it. So how we can do it a more clean way? A more clean way to do it would be defining that coffee decorator, which is an abstract class. It would just take a type of coffee, and then whenever whatever the cost is associated with it, it would be returning us. We look at the milk decorator, then we can just add inside a coffee of milk, then its cost would be the whatever the cost of the original coffee is, which we have passed it, and plus 2 rupees 2 idr is the cost of the milk which we are adding in this decorator. Similarly, for the simple coffee, it's just the amount which is associated with it. And in the sugar coffee, if we see, then we take up the coffee and we add 1 IDR for the sugar, and then the whatever the base price of the coffee it is. So these are the three ways. And then if we go to the coffee shop, then we can see the coffee. We created a simple coffee. Now we want to add in this simple coffee. We want to add a milk inside it. So we just in our decorator class we just pass the created coffee, and then if we see the cost associated with it would be the base price plus what is the price of the milk. Similarly, if we add sugar also to it, then it would be a milk coffee which is already been prepared, and then we added sugar into it. So sugar coffee would be the base price plus the milk price plus the sugar price. So if I run up this solution, so you can see that the cost of simple coffee is $5. The cost of milk coffee is $7. 5 plus 2 and the cost of sugar is 5 plus 2 plus 1, which is the $8. So we have decorated out the additional functionality which was given. A simple coffee was our first requirement, and the new additional requirement are being coming up with this, and then we have decorated out the new additional requirement without changing our original coffee class. So this way we provided a more cleaner implementation of the structural changes which the coffee class had with the new functionality this coffee class had. So this is the one of the structural pattern, which is the decorator pattern. So this is what I have explained, one most important patterns in all the three. Let me conclude this slide on the solid and design patterns. It is like as summarized above, that we need our code should be more robust, future-proof, maintainable, and adaptable to change. So that our code doesn't need to just like blow up in any of the new requirements that came in. So by following this design patterns and solid principle, we can lead to more cleaner, more modular code bases, and they promote reusability, scalability, and also ease of maintenance, which we do in day-to-day basis in any of our software engineering role, maintaining the old legacy code bases and getting interacted with the new functionality. So call to action is try to integrate solid principle with the current code bases so that you could make more more clean code, more efficient code, so that it is more future proof. Any developer which comes even after your leaving of the company just looks at your code and uh, helps to see, it would help him to see that how easier and how well the code is maintained. So it would be a great gift for anyone who would be working as at a very clean and good code base. So with this, if you want to connect with me, you can connect with me on this LinkedIn and also in this Instagram ID. So I have mentioned both of them. Amazon would share it to you guys. Uh, So this concludes up the. Also, I would like to share up the repository for this. Yeah, as let me stop sharing. Then I'll share up the repository for the code bases.
You can share it to participate.
Yeah, sure, sure.
Right. Thank you, Mr. Aman Singh, for that insightful presentation on the clean code, solid principle, and one of the key takeaway I'd like to highlight is as a developer, as a software, we, we would like to have a better way to code our projects, as in we have a way or a structure which we are adhering to so that we can make better, cleaner code on the long run so that we could benefit not only ourselves but the next developer that came into contact with our legacy code base. And as we move forward, having a solid understanding of these core principles will be invaluable for design pattern. So we would move to the next session, which will be a Q&A session. You can raise your hand if you would like to ask a question to our speaker. Anyone in the audience can raise their hand for them to have the permission to be unmuted. Or you can also use the chat function You can type in your question on the chat window. You could also do that. Any question from the audience? Hello?
Okay, can Tawfiq unmute us all, like maybe for any question or discussion or any?
So,
I think people are muted in this conversation.
oh yeah. I mean, they could type it on the chat.
Okay, guys. Maybe if you have any question to the speaker, just or maybe put your question in the chat.
You can unmute you if you want to ask a question directly. Just raise your hand. Yeah. Throughout the session, we learn about the importance of writing the logic code and also appear in the solid principle. So anyone else have a question about solid principles regarding clean code, modular code, regarding the design principles, you could use your hand and ask. We explored various design patterns as well. You could ask about the actually design patterns, decorator design pattern. Ask if you have ideas about.
There is no question. Hmm, we can complete the event maybe if there is no question.
There's no question, then which is close this event, which includes an insightful and engaging session on topic solid principle and design pattern. Once again,
Recording stopped.
thank our speaker, Aman Singh, for the time knowledge that he shared for us. And I hope you all feel inspired to apply these principles and patterns in day-to-day work. Because writing a quality code is an ongoing journey and see learning skills. Once again, thank you to our speaker and to all of you who participated in this event and engagement. Thanks for your engagement, and this wraps up Devtalks 3. Be sure to stay tuned for future sessions on exciting topics in the world of software development. I'm Ahmed, I'm the host of this event. So,
Okay, cool. Thank you, guys.
so much, Mr. Ahmed.
Thank you. Thank you guys for joining. If you are want to rewatch again in this session, you could go to the Makassar Developer Enthusiast YouTube account. So there is a live session there. So maybe the recording may be in that YouTube channel.
The
Thank you.
recorded session are available on YouTube, so be sure to check that out if you would like to see the pod. Also, be sure to check the GitHub that Aman Singh already sent on the chat. You can check all the materials are up there.